Hey, welcome back to the academic powerhouse with your mathematical meathead himself, the realest guy in the room. Bada bing, bada boom. How you doing? How you doing? Part two of the video in which we take our shapes, our visualizations, and convert them into our numbers and our calculations of center and spread. This is part two because I broke it up and I wanted to do mean absolute deviation. It can get a little involved and time consuming, so I just wanted to break it into two separate videos. So, with that said, I've already kind of pre-worked it out, but I'll explain what I did here. So, remember what mean absolute deviation even is in the first place. It is simply saying, mean absolute deviation. What it means is, the word mean is in there. That means you got to do something with mean, right? Sum over count. Okay, that should give you a clue. Deviation is the difference, but is anything that differs from the center. The center, in our case, being the mean, the mean that we calculated earlier. So anything that is not 70.36 is a deviation. We got to figure out how much each data point deviates from the center. And then absolute, meaning absolute value. In other words, we don't want negative numbers to influence the calculation that we do. So deviation. Well, first you figure out the deviation for each data point. For the sake of simplicity and brevity of writing, I have simply, instead of writing minus 70.36 a bunch of times, I simply said my 7036 is what is going to be called x bar. X bar. That's what that is called. X with a little line above it. So as you can see, I set up a little table here in which I listed each data point and I'm subtracting it from the center, from the mean. So 57 minus 70.36 equals 13.4. 65 minus the center equals 5.4. And now these are rounded a little bit, so your answer may slightly vary depending on how you rounded it. I just rounded it to the nearest tenth, but oftentimes I also like to round it off to the nearest hundredth. Just depends, guys. Just depends. Anyway, so when you do that, you got to do that for each data point. Each data point, and you're taking these lines here, mean absolute value. You're taking so these would have normally been negative, except because we're doing absolute value, they're all positive. They're all positive, right? That's what we care about, is the number, not whether it's negative or positive. So with that said, for each data point, take that, subtract the mean off of it, you get a list of values. You're essentially generating a whole new set of data points, a whole new set of data points from which to take a mean, a new mean. The average of all the deviations is essentially what you're doing. The average of all the deviations from center. So here you go. Here's all the data. Here's all the deviations from center. Add them all up. Divide by the total number of them. You get a value here, which happens to be your mean absolute deviation. That is the answer. And that is how I did all of these. That is the setup. That is the explanation as to how it works. That is mean absolute deviation. Again, it looks a little quick because I didn't actually write it here with you on video. I paused it, did the work, came back, recorded. So it looks a little quicker and simpler, but it can get a little time consuming, but absolutely necessary. Let's look at the next one. Same thing, same setup, same idea over and over and over again. So if you followed that process that I just outlined and the reasoning I just outlined on problem number one, you will find you come up with an answer for number two, this one here, number two, and that mean absolute deviation, 0.68. 0.68, guys. This one here, same stuff, just a little different. Well, actually, not at all different, in fact. Um, Same stuff. data point minus deviation. Get a list of deviations. Then take the average of all those deviations, and you get an answer, 2.44. Same here. Data point minus deviation equals something. All those somethings added together, divided by the total amount of those somethings, gives you a mean absolute deviation there. So that's it, guys. That's it. That is the full, this is part 2 of the full video on how to take a statistical visualization, a shape, and calculate its associated measures of center and measures of spread. And as I've said many times now, when you have shape and spread and center, when you have all three, they tell the story of statistical truth. Story of statistical truth. They tell the story that we're trying to tell. So, with that said, now we just have to get real good at this stuff through practice. I'll give you some more practice problems. We'll review the solutions together. And by that time, you should have a really good fundamental grasp on statistics. We'll probably cover a few other things that are important to know about statistics, but essentially, guys, we have come full circle in our 6th grade, 7th grade journey here on statistics. So with that said, I hope this has given you a really good pump. The previous video was mid pump. We're full pump. We're all the way done here, guys. Now I hope that your mental muscles are flaring up. They're burning up, and we are ready to tackle more because we will have more, guys. So for now, see you in the next video. Goodbye.